So to assemble the Ripcord generator, I'm going to take this puzzle piece and fit it into this slot here on the GPO circuit boards. Here is where our coil is going to go, but before I do that, I'm going to add the bolt and slide it into this recess. These two leads I can put on the pegs. In order to add magnets to the rotor, I need to remove this plastic nut from the shaft and then take the safety lid off of the rotor. You will see that there are 12 little pockets that magnets can fit into. And so I take a magnet and I slide it into these pockets. Now here's the thing. You want the magnets either to be facing all the same direction or alternating as they go around the rotor. Sometimes you can see the N and the S on my magnets, but some of my magnets are pretty goofed up. You really can't tell. But you know that magnets attract. And so if I want all the magnets going in the same direction, I would set them so that they all attract. If I want them to alternate, I use the same process and go, this one attracts, but then I find the repelling side and put it in the next pocket. Then I want a magnet to attract, and then I want a magnet to repel. Now I can put magnets in all 12 of these pockets, or I could put them in 6 of these pockets. A magnet, skip a pocket, magnet, skip a pocket, magnet, skip a pocket. Once you have all the magnets in, we're going to put this plastic cover back on and add the nut to it so that it holds the magnets down into the rotor. If you attempt to spin this without the plastic cover, these magnets can fly out and become projectiles. The final aspect of using the Ripcord generator is I'm going to use this string with a handle on one side and a knot here. In order to use it correctly, I'm going to thread it through this eyelet here and then use the knot and place it inside the hole that's on the shaft. Now I need to kind of hold it there as I start to spin the shaft. The objective is to get the cord to stay on the shaft. Okay, when it's time to use the Ripcord generator, I'm going to think of 3 things. Is my plastic plate on the rotor. I'm going to pay attention to who's behind me as I pull this cord. And then I'm going to put my hand right here to hold the whole thing down. If I want to pull slowly, I get the rotor to go, well, slowly. If I want to pull quickly, I apply much more force. In one experiment, I want all 12 magnets to be facing in opposite or alternating directions. So for example, that one's north facing that way, and that one's north facing that way, all the way around. I can do that by taking another magnet and seeing attract, repel, attract, repel, attract, repel, all the way around. I'm going to put my plate, to provide safety, and then I will add the cord through the eyelet so that I can rotate it. Now during this experiment, you need one of your partners to be measuring the voltage as well. In the second experiment, we would like all the magnets facing in one direction. And to be honest, it's kind of hard to get your fingers in here in order to get these magnets out. There is a trick. As soon as you have one magnet, you can use them to collect all the rest of the magnets. And then, now that I want magnets facing in the same direction, I can just simply put the magnets in order. A way to check is to take your magnets and see if they attract all the way around. In an experiment, it asks you to only use 6 magnets. And if I want them to be alternating, I want them to face this way and this way and this way. One easy way you can do that is with a set of magnets and see that this one attracts and this one repels and this one attracts and this one repels. Put your plate on. Pull with your cord and measure the voltage. In the next experiment, I'm going to arrange 12 magnets so that they are alternating. I'm going to add my plate and the safety nut. But I'm going to add a photo gate right here. And the objective is this window in the plate can go through the laser beam. And when it does, it counts how many times the rotor goes around. In order to set up my CPO timer, I'm going to use the frequency setting here, so that as the rotor rotates, it tells me how many times in 1 second that thing spins. During this experiment, we would like to know the frequency as well as the voltage that is measured as our rotor spins. We can do that with our cell phone. If I take my cell phone and videotape both of these screens at the same time, then I can play back the movie and record what the rotation is and what the voltage is of one single experiment. If your phone has a slow-mo feature, this gets easier and easier. In one experiment, it would like the bolt to be very close to the coil, the rotor. But you can adjust that by loosening these finger knobs and pushing so the bolt is very far away from the rotor in order to see what happens to voltage.